I'm the Regional Climate Services Director for the what we call the Central Region, which is really the central part of the U.S., north central part of the U.S., I should say. And I'm joined here by Dennis Toddy, the USDA Climate Hub Director from the Midwest, and Zach Holloman, who is going to do the presentation. He is an assistant state climatologist with Montana. We do these every month, as you probably all gather, and at the end we have a Q&A session. Zach will probably take around 40 minutes. There's a lot to convey this month, and I just want to let everybody know, in case there's a major blip in this webinar series, or webinar today, is that I'm sitting in a hotel, and I hope the connection holds, because it's raining or snowing and blowing here in Omaha. So thank you. And Zach, why don't you take it away?
All right. Well, thank you very much, Doug. And I'm excited to be here today and to present the climate and drought outlook for the North Central U.S. region. Like Doug said, my name is Zach Hoylman, and I'm the Assistant State Climatologist for Montana, and I'm also a Research Assistant Professor at the University of Montana. The 2022-23 winter has been one for the record books, with extremely wet conditions across the western lake states, fueled in part by a series of atmospheric rivers coming from the Pacific coast. Despite this wetness, conditions have also been relatively warm, especially in the eastern portions of the domain, making for an interesting conclusion to the winter season. So there's a lot to cover today, but before I get started, I did want to mention that my presentation today draws from information, data, analysis, and many helpful discussions across state and federal partners. And specifically, regional climate services for the North Central United States are provided by state climatologists, the American Association of State Climatologists, and various state climate offices. Also, the National Oceanic and Atmospheric Administration, the U.S. Department of Agriculture, the Midwest and High Plains Regional Climate Centers, as well as the National Drought Mitigation Center. And just so you don't miss it, the next webinar will be on April 20th at 1 p.m. Central, and the presenter will be Dennis Toddy, again from the Midwest Climate Hub. You can access future climate webinars and information at the link listed here. And finally, you can find recordings of past webinars via the Regional Climate Center links shown below. All right, so my presentation today will focus on how the conditions we've experienced in the last couple of months compare to historical conditions, how these conditions affect our progression into the spring melt and runoff season, some of the current and prospective impacts that we've experienced, and a discussion of recent climate and drought outlooks. I'm going to attempt to complete this all in the next, say, 30 to 40 minutes, hopefully closer to 35 minutes, and we'll wrap up with time for questions and further discussion. So let's begin today's presentation by looking at recent conditions over the last few months. More specifically, let's start by taking a look at temperature and precipitation rankings for the last 3 months. These rankings are from NOAA's Climate Prediction Center and compare December through February average temperature and precipitation to those that have occurred for the last 128 years. Larger numbers, up to about 128, indicate very warm conditions in red, or very wet conditions in green on the left and right hand, respectively. Smaller numbers down to 1 indicate increasingly cooler temperatures in blue or very dry conditions in brown. The figure on the left shows statewide temperature ranks. In general, the majority of the upper Missouri River Basin has experienced relatively average temperatures over the last 3-month period. As we move east into the upper Mississippi, temperature over the last 3 months has been above average. Further east still, going into Illinois, Indiana, Ohio, Missouri, Arkansas, and states to the south and east have largely experienced well above average temperatures indicated by the salmon coloration in the map. In many cases, these states have experienced the second warmest winter on record, as shown by any state marked 127. So it's been a very warm winter in the Midwest and the surrounding states eastward. Moving to the right, the 3-month precipitation rankings show a different pattern. It's been relatively wet in the lower portions of the upper Missouri River Basin and exceptionally wet in the upper reaches of the Mississippi and along the western Great Lakes states. In fact, according to NOAA, Wisconsin experienced the wettest winter period on record, going back 128 years, and Minnesota recorded its second wettest winter. Nearby states, including Iowa, Nebraska, were very close to achieving this record, with only 3 or 4 states having been wetter respectively. So what caused this extreme wetness? Well, at least a component of this moisture can be attributed to a series of atmospheric rivers that paraded through the United States this winter season, starting from the California coast and moving all the way north and east to the Great Lakes region. These storms have caused serious impacts, which I will cover later on in the presentation. Okay, let's move on to last month's ranking. Here I've shown the same maps as in the last slide, but with temperature and precipitation rankings for February only. So a 1-month period instead of a 3-month period. Patterns of temperature and precipitation in February were generally similar to those that we saw in December and February. As you can see, the majority of states in the central region are warmer colors, indicating above average temperatures. Generally, there's a gradient from west to east, where conditions become progressively warmer the farther east we look. February was the second warmest on record for Ohio, Kentucky, and the third warmest for Tennessee. But all in all, the 3 months and 1-month temperature patterns were pretty similar. It's been a very warm winter, to say the least. Moving on to precipitation, we see similar patterns to those of the 3-month summaries, where the Great Lakes states experience much above average precipitation, especially in Wisconsin, Iowa, and Michigan. In a minute, we will explore what these anomalies in precipitation may mean for runoff dynamics. Before we do that, let's take a look at precipitation and temperature over the last 30 days. On this slide, again, I've shown minimum temperature departures from normal and on the left, and maximum temperature departure from normal on the right for the last 30-day period. Temperatures from this window of time are compared to those observed over the 1991 to 2020 climate normal. Yellow and light green colors indicate near normal temperatures. Green, blue, and purple colors represent colder than normal temperatures, and orange to red colors indicate warmer than normal temperatures. Starting with the left, generally, minimum temperature anomalies over the last 30 days have been between 2 to a whopping 20 degrees Fahrenheit lower than normal in the upper Missouri River Basin, including portions of North Dakota and parts of Wyoming. Once again, moving to the east, we see a very different story. Here, minimum temperatures over the last few weeks have been well above normal, extending from Iowa and Missouri eastward. Temperature anomalies have been between 2 to 10 degrees Fahrenheit warmer than normal. This continues a trend of much warmer than normal conditions in the western Great Lakes states and moving southward. Moving to the right, average maximum temperature anomalies exhibit similar patterns. Generally, the upper Missouri River Basin is experiencing well below average max temperatures, in some areas reaching 20 degrees Fahrenheit cooler than normal. And this cooler than normal pattern extends to farther to the east when compared to the minimum temperature anomalies. States like Wisconsin, southward, are experiencing warmer than normal temperatures over this last 30-day period. Let's quickly move on to precipitation over the last 30 days as a percentage of the average value. As an example of how to read this, dark red areas represent 0 to 5% of average or almost no precipitation. Yellow and green areas would represent approximately 100% of normal precipitation for this time period or close to average. Dark green, blue to purple shading indicates upwards of 200 to 400% or roughly 2 to 4 times the normal precipitation. Precipitation patterns for this time period have been spatially variable, as you can see. However, in general, the northern portions of the domain, extending eastwards through Minnesota and Wisconsin, have experienced well above average precipitation. In other words, the extreme wetness that has been observed between December through February in the western Great Lakes states has continued into March. Meanwhile, Nebraska, eastern Colorado, and Kansas are experiencing precipitation deficits. As a reminder, this map shows the liquid precipitation over the domain, or rainfall, or the amount of snow that would be melted into rain. But what about the total snow water equivalent accumulated across the entire snow season? We'll explore this next. Here I'm showing the total snow water equivalent, or SWE, that has been accumulated throughout the entire season as estimated from the SNODAS dataset. SWE is the amount of water that would exist at a point if you were to melt the snowpack at that location. It's a useful measure of how much water is in the snowpack. Blues on this map represent 200% of average, while yellows represent roughly average conditions, and red represents well below average. As a note, snowdust anomalies calculated here are with respect to the 2004 to 2023 period of record, so a relatively short period of record. However, as you can see, essentially the entire northern portion of the central region has experienced well above average snow water accumulation for this time period, especially in Wisconsin, Minnesota, and North Dakota. Snow is well below average in the northwestern portions of Michigan. There's some concern that this large and persistent snowpack could cause flooding, but I will cover that later on. As an interesting note, the Great Lake ice extent from November 10th through March 15th is tied for the third lowest on record. So while there's plenty of snow, the Great Lake ice cover is lacking. Here, I'm showing a slightly different rendition of snow water equivalent. Here, the difference from average conditions. So blue colors here represent more than average snow water, while brown indicates less than normal snow water. As you can see, the Dakotas, Minnesota, and Wisconsin are well above average, with large swaths of the state showing 4 or 5 inches more water in the snow than expected at a point. That's a lot of water. Digging in a little bit deeper, here are the seasonal SWE accumulation time series from the Army Corps of Engineers for the Platte and Missouri River basins. Red lines represent average conditions, while the shaded blue region represents this year. As you can see, this year's accumulation has been very close to average according to this analysis, with the North Platte well above normal. Moving on now to soil moisture conditions. As a note, the average to well above average snowpack has yet to impact the soil moisture percentiles at depth shown here in this map. So it isn't surprising that we don't see considerable wetness along the western Great Lakes quite yet, though the full influence of this melt season will be strongly dependent on where and when soils are frozen. Okay, jumping back into the graphic. Here I'm showing soil moisture percentiles estimated by the NLDAS soil moisture model. Low soil moisture percentiles from, say, 20 to 1% are indicated with light orange to red shading. Surpluses of soil moisture with percentiles ranging from about 80 to 100% are indicated by light green to dark blue shading and show much wetter than average conditions. Generally, you can see that the southern portions of the north central region are experiencing a long-standing soil moisture deficit, as indicated by those dark red regions extending from the Dakotas south and eastward. The most severe deficits occur in Nebraska and Kansas currently. As we will see later in the presentation, these long-standing multi-annual precipitation deficits and the resulting soil moisture deficits are influencing long-term drought depictions in this region. Looking directly at current stream flow conditions now, here's a map of USGS stream gauges and flow rankings across the United States for the last 28-day period. Across the gauge network, blue symbols represent above average flows, green symbols represent average flows, and orange to red symbols represent well below average flows. Stream flow conditions in the upper Mississippi are already very high, with several gauges reporting higher than the 90th percentile, as shown in blue. In general, gauges in Wisconsin, Iowa, and Illinois are also high, exceeding the 75th percentile in many cases. Stream flow conditions are relatively average in northern Missouri and eastern Nebraska, and relatively low further to the west in central Kansas, where we will see in a minute is where the majority of the extreme and severe drought conditions persist. As a note, many gauges are not reporting this time of year due to ice in streams across eastern Montana and the Dakotas. And interpreting stream flow percentiles during the winter should be done with great care. It's very dependent on the timing of runoff. A more holistic picture of stream flow conditions and general runoff dynamics will be available during next month's webinar with Dennis. Many of you may be wondering, how do these relatively high stream flow conditions in the Mississippi and strong seasonal snowpack bode for our flood forecast and predictions? Well, let's take a quick look, moving basin by basin. Here I'm showing the 50% probability of exceedance for different flood states at various gauges across the upper Mississippi. This represents the 90-day or springtime outlook for potential flooding across the major river basins. For this figure and the next several figures, green symbols represent no enhanced chances of flooding. Orange represents enhanced chances of minor flooding. Red indicates enhanced chances of moderate flooding, and purple indicates enhanced chances of major flooding. According to the National Weather Service, flood risk along the main stem Mississippi River from Twin Cities area down through about Keokuk, Iowa, is well above normal. As you can see from this map, there is enhanced chances of major flooding that will occur along the main stem of the Mississippi in many locations, as indicated by those purple symbols. The forecast for the Ohio River Basin is much less severe, with relatively normal flood risk dominating the forecast across the basin. However, please note that there is an elevated risk of minor flooding in the Ohio Valley, as you can see by those orange and red dots. Finally, looking at the Missouri River Basin, it is noted that flood risk varies significantly across the basin. Flooding is not expected across the upper reaches of the Missouri River. However, the main stem of the Missouri is likely to experience episodic floods from about Nebraska City downstream to the mouth of the river. Okay, now let's take a quick look at the current reservoir conditions along the Missouri River Basin. This graph shows a combined storage capacity for the Fort Peck, Garrison, and Owyhee River reservoirs in millions of acre feet. The orange dashed line shows system storage in 2022, and the red line is this year. The dashed blue line in the middle represents the average storage of the system over time. Currently, system storage is below average for this time of year and lower than this time last year. According to the Army Corps of Engineers, despite some improvements in basin conditions, the 2023 calendar year runoff forecast for above Sioux City is about 21.5 million acre feet, which represents about 84% of average. So
hey,
now,
Zach?
yes, yep.
Yeah, I'm going to have you back up to that upper Mississippi map, if you will,
Sure.
real quick, because I just want to mention one thing before I forget.
Sure.
Is that all these snow melt areas, and there's a huge snowpack in this area, the northern part of the area. A lot of this flooding is, a lot of these flooding predictions take into account the likelihood of that snow melting, of course, but the dependencies or some of the things, the variables are how fast that snow melts. It's not just how much snow, it's how fast it melts, and if we get a rain on snow event. And I just want to make that sort of clear that all this is not a foregone conclusion. It matters on how the snow, as we say, comes off. And the later we go into the season, the later we push and hold on to a snowpack, the more likelihood there is for a fast warm-up as well as heavier rainfall events. We've seen that many a time. So we like to see it sort of slowly melt away. And the risk of that not happening increases with time as we get later into the warm season. Sorry for interrupting. Back to you.
Absolutely. That's all really good information. Thanks, Deb. All right. So how have these warm conditions that we've been talking about impacted our spring phenology, or the green up of the different plants across the country? Well, here I'm showing spring leaf out anomalies for March 15th. Red colors represent earlier than normal leaf out, and blue colors represent later than normal leaf out. As you can see, spring is sprung early for the southern portions of the central region, generally tracking this anomalously warm temperatures. We'll keep track of this moving into the future as the full spring kind of season emerges. So let's conclude the current conditions portion of this presentation with a look at today's drought monitor that has been released today from the National Drought Mitigation Center. In response to long-standing dryness in this region, drought remains a pervasive component of this landscape, especially in Kansas. According to the USDM, the majority of the central region is classified as experiencing long-term drought conditions, generally consistent with 6-month or greater anomalies in terms of timescales. However, in some places, precipitation deficits are reflective of more than 3 years. This is consistent with the USDM's long-term representation of drought in the region, where D3 or extreme drought has appeared on at least portions of the central region since early 2000, as you can see from this time series plot at the bottom. I'll put my cursor at about the early 2000s there. 2020, excuse me. But what about recent trends in the USDM? Here I'm showing you the 8-week change map for the USDM. Green colors represent improvements in the USDM drought classifications, while yellows and browns represent degradations. In general, drought has been improving across this region for the last 2 months. This is likely in response to well above average precipitation and a strong snowpack like Doug and I were discussing. As encouraging as this is, large regions of drought remain, indicating that we have a long way to go before this region is fully out of this multi-year drought. Now I'm going to transition and highlight some of the impacts that have occurred over the last few weeks, starting with some extreme wetness in the western Great Lakes states. This winter in Wisconsin, Minnesota, and Michigan can be summarized as a season with significant winter events bringing ice storms and heavy snow. As I said before, this winter was the wettest on record for Wisconsin and the second wettest for Minnesota. A significant ice storm occurred on February 23rd across Wisconsin and Michigan that caused significant power outages and downed trees across Wisconsin. This storm resulted in 800,000 homes and businesses losing power in Michigan and canceled almost 800 flights in this region as well. A whole ½ an inch of ice accumulated during this event in some locations, which was responsible for a lot of this impact. Then on February 27th, heavy rains caused significant flooding in southeastern Wisconsin. This event was Milwaukee's wettest day in February ever recorded and equated the entire amount of precipitation expected in the entire month of February. In other words, it was a month's worth of rain in one day. And finally, on March 14th, a heavy snow event in Minnesota caused a mall roof to collapse in Duluth, Barnes & Noble. To say the least, it's been an extreme winter for these locations. Okay, moving on to Kentucky and Indiana. Here, Kentucky has experienced an exceptionally windy and warm winter. In fact, 2023 was the windiest year on record in this location, and they recorded up to 70+ mile-an-hour winds in Kentucky. February average temperatures soared to more than 8 degrees above average, which represents the second warmest February on record. Winter was almost 6 degrees warmer than average, which is causing a very early start to spring, which we saw in the phenology map. And in Indiana, an extreme rain event dropped almost 4 inches of rain in 2 days, causing debris flows. Although these debris flows weren't mud and rock, which is what I'm accustomed to seeing in, say, the northern Rockies. Instead, this was full of corn stalks that continued for over a quarter mile. All right, now I'm going to transition to the outlook portion of the talk and discuss what conditions are expected over the next several weeks to several months. Here I've shown the National Weather Service 7-day quantitative precipitation forecast for the United States. Colors here represent the depth of expected precipitation in inches. The expected values in our region range from about 1/10 of an inch in green to upwards of 2 inches in light purple. The key area I'll draw your attention to is a storm system that is forecast to drop between roughly 1 inch to upwards of 1.5 inches of moisture over the already soaked Wisconsin, Minnesota, and Iowa. This system extends southward and eastward as well. As I showed in the impact section of the presentation, this location has already experienced significant impacts due to the winter extreme wetness, and it appears that this wet trend is expected to continue in the short term. Okay, Now let's move on to the longer range outlooks and see how long this anomalously wet event may continue or may be expected to continue. Here are the Climate Prediction Center's 8 to 14-day outlooks for temperature on the left and precipitation on the right. Temperatures are leaning below normal for the majority of the western portion of the region, as indicated by blue shading on the figure to the left. However, as we move to the upper Missouri River Basin towards the Midwest in the east, temperature is expected to be near normal. It should be noted that large portions of this outlook's probability in our domain are low, and therefore confidence that the below average temperatures will occur in, for example, Minnesota, are limited. Moving now to the figure to the right, light green shading indicates that the majority of the region is leaning towards above normal precipitation. However, again, the probability that above normal precipitation will occur is relatively low. Okay, moving on to the 1 month outlook now. On the left, I'm showing the temperature outlook, and on the right, precipitation. Starting with the left, the majority of the upper Missouri and upper Mississippi regions have equal chances of being above or below normal. As we move east towards Michigan and Ohio, the outlook suggests that probabilities are leaning towards warmer than normal temperatures. If this occurs, we will see a continuation of the anomalously warm conditions in this portion of the central region. Moving to precipitation on the right, there are equal chances of above or below normal precipitation across the majority of the region. However, the outlook is leaning towards above normal precipitation across Wisconsin and Michigan. Again, these probabilities are in the 30 to 50% range, indicating only moderate confidence in these forecasts. Going out a bit farther still to the 3 month outlook, the majority of the country has a greater chance of experiencing above average temperatures. However, the upper Missouri, the upper Mississippi basins are predicted to have equal chances of above or below normal temperatures. Similarly, there's generally equal chances of above or below normal precipitation, moving to the right, in June, July, and August. As you can see, there are some portions of Michigan, Ohio, Kentucky that are leaning towards above normal precipitation. Looking past the 3 month outlook, it is important to now consider El Nino, the El Nino Southern Oscillation, or ENSO, and changes in the Pacific Ocean sea surface temperatures. These can impact regional air circulation patterns and in turn air temperatures and precipitation. I've shown the March ENSO forecast in the left-hand figure here. Gray bars on the left-hand side of the graph indicate that the probability of neutral ENSO conditions dominating the forecast until mid-summer. So in the near term, neutral conditions are expected. However, red bars indicate an increasing likelihood of El Nino conditions dominating going into the fall and throughout next winter. This is a large switch from the last several years, which have been dominated by strong La Niña signals. In fact, the last La Niña event this last winter was a triple dip La Niña, which is actually relatively uncommon. So what drives this ENSO phase? To the right, I'm showing the current sea surface temperature anomalies off the equatorial Pacific, which play a strong role in determining an ENSO phase. As you can see, temperatures are near normal along the equatorial line, which is indicative of ENSO neutral conditions, hence the high likelihood of ENSO neutral in the near-term forecast. When sea surface temperatures along the equatorial Pacific are warmer than normal, this is indicative of El Nino conditions, and cooler than normal is La Niña. Finally, let's discuss the seasonal drought and wildfire outlooks, starting with the drought outlook on the left. Similar to recent trends in the U.S. Drought Monitor, improvements in drought conditions are expected to continue throughout the spring, according to the Climate Prediction Center. Further, development of new drought conditions are not currently forecasted for the upper Mississippi and Ohio river basins. Switching now to the forecasted fire potential on the right, we can see that normal conditions are expected across the region, with a small area below normal activity expected for Kentucky and the surrounding states. So to summarize the presentation, recent conditions in terms of precipitation have been wet, especially in the western Great Lakes states. These conditions have caused some serious impacts due to wet, heavy snow and ice. It has been a very warm winter in the Midwest, but relatively normal in the upper Missouri River Basin. Current snowpack conditions show that there's a lot of snow yet to melt in the upper Mississippi and upper Missouri River basins. The season-long wetness and strong snowpack are causing elevated risk of flooding along the upper Mississippi. Drought conditions are generally improving in the north, yet are still extreme in the south, especially around Kansas. Short-term outlooks are leaning towards a continuation of wet and cool conditions, while long-term outlooks are leaning normal warm and normal dry. ENSO conditions are now transitioning to a neutral phase, with a higher probability of El Nino going into the fall and next winter, and wildland fire potential is expected to be near normal, with below normal fire risk expected in Kentucky and the surrounding area. And now I'd like to hand the presentation back to Doug and begin the question and answer portion of the discussion. Thank you very much for your attention.
Thank you, Zach. That was very helpful, and way too much, as usual, way too much information, but I hope people got a good flavor for what's going on and what may happen. We have a number of questions, and one thing I did say, even though I did say we had a question and answer session at the end, is please, as we go along, although it's too late, put your questions, whatever they happen to be, or comments, into the question panel, not the comment panel or the chat panel. That's what we kind of watch as we go through this. So thanks, Zach, and thanks, Dennis, because I know you're going to answer some of these questions that are sort of crop related. But one of the first things that came up is when is the drought going to be relieved, or any relief really, in the Nebraska, kind of southern central Nebraska, south into Kansas and really high plains area of all the way down probably into Texas, in terms of drought. And I think you showed the map, you can bring it up again, Zach, of what the outlook is. And I think that's through the end of June. Drought outlook, sorry, drought outlook.
Oh, sorry, yep.
Yeah, so that's the official outlook, yeah, through the end of June. And a couple things just to say really quickly about the overall pattern for the last 3 years with La Nina is that springs tend to be dry in the southern plains, especially in the western high plains, and sometimes that reaches up all the way up into South Dakota. And we've seen that. We've seen a transition this winter into a portion of that. Much of Nebraska has gotten better in terms of drought. Not so much in Kansas. They've been a little bit too far south. There are portions of Kansas that are doing okay, but this outlook, that brown area, really calls for no improvement during that time. The greenish and grayish sort of colors. Green says drought's going to go away. Gray kind of says drought's going to get better. And so that's the current outlook through the end of June. If you ask me when is Western Kansas actually going to see all their rain, what I'll also say is that spring is a better time of year. As we all know, we tend to get spring rain, spring precipitation into June at least, before things begin to dry out again. So from that perspective, just from a pure climate point of view, we ought to see some improvement there. If we don't, I don't need to tell anybody that's going to be more of an issue. Okay, Dennis, do you have anything you want to throw in on that, or Zach, on drought improvement, and when we can predict that?
I mean, the other thing, just to reiterate my comment I put in there is that the severity of the drought is very large. So there's a good chance we may improve, but still have ongoing drought because of the severity of the drought.
Okay. Yeah, and absolutely. And places like Kansas, like we were talking about, are experiencing multi-annual precipitation deficits out to 3 years. And I believe in certain locations, they're actually 30 inches behind on those 3-year accumulations. So, that level of precipitation deficit over that long of a time period is going to require kind of consistent above average precipitation and moisture conditions, cool conditions to, start to chip away at those long-term deficits.
and really kind of depends on the sector you're worried about. If you're very interested in wheat, for example, it's a different story. You know, you can get enough short term, I guess you could say, and Dennis, you can talk more about that. Short term precipitation that can get you through. But as far as deep soil moisture and recharge and all that business, it's a different story. So Dennis, do you want to say anything about that?
Well, yeah, and that was the other thing I was going to follow up with too, is that we struggle. How do we show resolution of the drought? And we could get some rainfall that improves the situation, but still leaves some of these, the comments that Zach made, some of these very long-term deficits, big deficits, we may not overcome for some period of time. So we might have enough to kind of limp crops by and some things like that, but still have longer term, deeper soil moisture and water deficits that we don't resolve.
Right. Zach, I don't know if you want to try this or not, but please discuss the current Pacific decadal oscillation and its relationship to dry conditions. We'll just say I think it's saying broadly in the region, but I think we can talk about the Central Plains, Montana to Texas, really. Do you have anything you want to say about that?
I am looking at, I mean, it looks like, so we're still in a negative phase as of through February in the PDO oscillation. And, I don't see that's persisted for, basically since 2020. So I'm not 100% confident on what the negative PDO phase has for the southern portions of the central region. Dennis, do you know, or Doug? Well, I know that we're remaining in that negative phase right now, as of now.
Well, yeah, and so the PDO and La Niña and El Niño, for that matter, often sort of shake hands. And one thing I wanted to say about the La Niña ending, because officially it is over, is that the atmosphere still hasn't transitioned to a different behavior. So what that means is the ocean has, but now the atmosphere needs to catch up, and there's almost always a lag. Now that lag can be 1 week or it can be a month. So there's going to be a lag and a continuation, if you will, of probably what we've seen. And honestly, if you talk to some of the climate forecasters, they said this year has been a very La Niña-esque year, even though it didn't perfectly fit our correlation patterns. The atmosphere is very, very La Niña-ish. So it's going to take some time for that to happen. Now, how the PDO is involved, if someone else wants to comment, feel free.
I say the other thing is we typically don't talk about the PDO influencing annual because by name, decadal oscillation, so it tends to flip back and forth on a 10-year-ish time scale. You're in one or the other. And I remember there was a paper, I think the cold phase connected with La Niña a little bit better, and the warm phase connected with El Niño a little bit better, and the opposite phases tended to work against each other. But it's a specific year in the PDO, I don't think we talk about too often.
Yeah, I mean, typically negative PDO is associated with kind of dry anomalies in kind of the Southwest moving over towards Texas. But I agree that, it's hard to say since it is more of a decadal oscillation than annual impact.
Okay, I'm going to move on a little bit. This is really for Dennis. After the above normal winter precipitation, will corn and soybean yield potential be less dependent on summer precipitation? Good question.
And we're going to say that we don't know yet, because here's the situation. The additional rainfall in the eastern Corn Belt, soils have not been frozen, so we're starting to refill that soil moisture profile. Even today, I heard from the Illinois State climatologist, even with some of the heavy rains, the water has kind of disappeared, so the soil is taking it up. If we continue on the wet side, we have potential for being delayed planting, slowing the planting down. As we get into like western Iowa, the northwest Corn Belt, there's a big unknown up there because we've had a ton of snowfall. We have a ton of water, like Zach hit on there, that's going to produce potential flooding. But a lot of this is falling on top of frozen soils. So a lot of that water is going to run off and go someplace else and not enter the soil profile. Some of it will get into the profile. So I think despite all that snowfall, we're still going to have some relatively dry soils up there. We don't know the details of that because we don't have good soil moisture measurements that understand that and can depict that very well. So we hope to find out more about that as the spring goes along here. But we still have some relatively dry soils that are not going to be fixed by that snowfall. We're still going to need some more rains on top of this after the snow melts.
Okay, thank you. Moving on, because there's a series of questions here. Someone is studying bat behavior, I believe, and is interested in how heat waves are defined and how you determine how a heat wave may have occurred with past temperature data. Number one, yes, I'm sure you can look at past temperature data, which again we have for over 128, 129 years or whatever, depending upon your spot. Now, is it local enough? I don't know, but I think we're going to have a conversation about that. It's also how you define a heat wave is really dependent upon. I don't know anything about bats, so a heat wave to a human is probably a little bit different than a bat, maybe not much, but it'd be interesting to know what affects the bats and how hot it needs to be and all that kind of business. Is there humidity involved? All those things. So what I'm going to say, Corinne, is to write me an email. I'll ask some friends and cohorts and others how a little bit more about that, and we can probably get you a better answer and show you where the data is. Dennis, are you a bat expert by chance?
No.
Okay, I'm going to move on. So heavy rain on Wisconsin on snowpack as we speak. Someone is mentioning that. Was that expected 7-day forecast? Yes, I believe it's not. You know, if you're going to say it's going to rain or snow in Wisconsin or Minnesota over the next week or month, I'm just going to say you bet. The pattern has been fixed. Okay, the pattern has been fixed. It's not always like that, but golly gee, that those systems coming in California really do continue all the way across the U.S. Now, sometimes they get shunted off into Canada a lot faster, or they take a southern track, but these haven't, and there's no indication that that's going to change. So thus the flood worries are heightened. The risk is increased. It would be great someday to show the 1 to 3 month predictions. I get from precip in a split screen with the same periods after they've occurred, just so we could roughly compare how good the predictive models are. No, Carolyn, I'm going to say that would be too embarrassing. I'm sort of joking, sort of not joking at the same time. It's difficult, and I'll just let everybody else know. If you looked at Zach's, maybe pull up the 3 month temp and precip outlook for us. Those probabilities on there are very light. In other words, not strong, not a lot of confidence, except for some of the temperature ones. Otherwise, the majority of the area has very slight leanings one way or the other, especially on the precip side. So yeah, we can discuss that more on a later date, I suppose. Oh boy, someone has left already, but maybe there's a little bit of interest. I'll just poise the question: will the Colorado River system still be persistent drought and drop down further? Are water wars ahead? I don't think they're ahead. I think they're now, by the way. And then the Colorado River is, this is a Band-Aid. This year has been a Band-Aid in terms of helping the system as a whole. In no way will it resolve the multi-dimensional drought that is going on in the Southwest. But it is a step in the right direction.
Yeah, briefly, Doug, there's a guy out of Colorado. He's a water guy out of Colorado at Colorado State University. The number he used was the Colorado River system would need 150% of average precipitation for the next 6 years to resolve the situation. And that's an astounding number.
Yep.
Nonetheless, this year has been good for the West, for the most part, not everywhere, but for the most part, broadly. Zach, if you want to go find it, you can show the percent of normal snowpack SWE out there for the entire West, but don't worry about it too much.
I've got it right here too. I mean, it just shows that it's 200% in a lot of the Sierras, continental U.S. over on the left here. So,
okay,
you know, the red is a little bit misleading because there's not much snow, obviously, usually down in the southern parts of the United States, but you can see the Sierras and big portions going over towards, you know, Nevada, et cetera, are all well above normal.
Right. The next question kind of goes back to what Carolyn asked. I just wondering about the accuracy of predictions. Do you have any statistics percentages on accuracy? Intuitively, accuracy is expected to decrease with a longer outlook. Generally, that is true, Nick. There are some weirdnesses in the monthly outlook that make it harder to. I'll call it noise interference that make the monthly outlooks harder than the 3-month, believe it or not, in terms when you sort of look at the accuracy overall. For our area of the world, the north central part of the U.S., predictions aren't the best unless we have a strong El Nino or La Nina sort of situation. Also, our predictions tend to be better during the cool season. So during the winter season, it's a little easier because we have better connections and we understand them better than sort of the randomness almost of what happens in the summer. We do have indications in the summer. Don't get me wrong. We base it on something, right? And we do have a lot of models, but accuracy isn't something that. And there are Heidke skills scores for all of that, and it is kept track of. And I don't have the link off the top of my head, but I do believe it exists on the CPC, the Climate Prediction Center's website somewhere. Someone wants to find that, feel free to put it in here. I'm going to move on because we have several more things to say fast. Please discuss the current Madden-Julian phase. Is it impacting the current Pacific jet stream pattern? Oh, golly. Zach?
Zach, are you a MJO guy?
I am not really, no. I'm looking up the phase right now, though.
The different phases of the MJO are correlated with different patterns across the U.S. And I had been noticing that we were in apparently a very strong MJO pattern, but I don't know where we were. That's all I can say about it.
Okay. And while Zach kind of looks that up, I'm going to move on. How will the transition to El Nino influence the atmospheric behavior during the summer? There's only a 60% chance of El Nino sort of coming back or starting again this fall. 60% is not a huge probability for that kind of thing. We're also in the time of year where we call it the spring barrier, and it's really a barrier to prediction on what's going to happen in the ENSO region of the Pacific, the equatorial Pacific. And I won't go out on a limb on that. You know, most of the folks, I suppose, at the prediction center are leaning towards, probably an El Nino happening. How it affects summer, it won't, but it'll be something in between. And I think Dennis has the perfect forecast. So go ahead, Dennis.
Well, you have to come back next month to get the perfect forecast.
That's right.
To play off Doug a little bit, I think it seems fairly likely that El Nino will occur. It's a matter of when it gets rolling. You know, is there a chance it gets started by late summer? Possibly. More likely fall, I would think. Fall into early winter. But I would say the big benefit is that we're getting away from La Nina, and I think La Nina has influenced us somewhat over the last couple of years.
Okay, thanks, Kevin Lau. We got 150% of seasonal volume for the Colorado Basin. Yeah, so one thing to talk about any basin, including the Missouri Basin, is you can have 150% of snowpack in the plains and in the mountains, and if you've just coming off 3 years of drought, that you don't get 150% of runoff. Okay, I hope that's obvious to folks, because soils really suck up a lot of that, and so do reservoirs for that matter. So you might see out of 150%, you may see 120% or less, depending upon the situation. Oh boy. So yeah, this is a question for Zach. Okay, very specifically, Zach.
Okay.
Is it accurate to say Montana has now emerged from severe drought conditions it has experienced over the last 5 years, and can crop and livestock producers anticipate a quality harvest in the season ahead?
Man, that's the $1 million question right there, huh? I think it's really, really challenging to say. There's certainly been improvement across Montana, and this year's snowpack, especially in the Southwest, like in the Big Hole and the Beaverhead, and some of those tributaries going into the Missouri River are pretty good. We're seeing quite a bit of snow in these areas. That being said, there's still long-standing moisture deficits across many portions of the state. You can see, I mean, there's kind of emerging drought conditions that are kind of playing off of the existing drought conditions in the West. So I would say this is going to be probably not the answer you're looking for, but I would say that it's going to be highly dependent on what spring brings. I think what we've learned over the last several years is the springtime recharge of soil moisture conditions is absolutely critical. And depending on how much precipitation we get basically in April, May, and June has a huge impact on soil moisture conditions, which are of course driving pasture and range conditions going into the summer. So it's going to be hard to say. There's always the possibility of an extreme event like in 2017, the flash drought that occurred across big portions of central and eastern Montana, which even though conditions were relatively favorable going into that season, we had quite extreme aridity in the atmosphere that sucked up all that available moisture in the soils and ultimately caused huge impacts across the state. So I'd say it's almost nearly impossible to make that forecast into the summer, but I will say that keeping a close eye on how conditions kind of evolve from April through June, especially in kind of the central portions of the state, we're talking, in Golden Triangle up along the High Line, and over towards kind of northeastern Montana are going to be really, really indicative of where we're going. And will probably be one of the most determinant factors on how the summer season goes.
I think what Zach is saying is that it's better than it was last year at the same time. Is that correct, Zach?
Yeah, I would say that is true. I mean, we still didn't see the kind of recharge to soil moisture storage that we were hoping for last fall before the freeze up. But it seems like conditions are slightly better than they were this time last year, I would say.
Okay, someone's asking about the Platte River levels and any chance of recharge before the growing season. And what I would say about that is I have talked to folks at this week actually, and in Nebraska, and saying there probably won't be any issues in the North Platte system, which is well over 100% of normal snowpack. In terms of irrigation, there won't be any allocations, restrictions, or anything like that. Likely, I'm not saying that's a for sure. That's just this guy off the cuff said that. South Platte is a different story. I don't have a feel for that, and I don't have any data for that. Maybe my good friend Kevin Lau would want to comment or write something in there. So I would say the Platte River, and the North Platte is the major, I guess, provider when it gets to Nebraska, after it gets through, when the two Platte systems come together. So I would say it's probably better, definitely a lot better than it has been, due to the snowpack on the North Platte. Any other questions or comments folks have? If you have any extras or any other things, you can always write any of us. Go back to our contact page, if you will, Zach, at the very end, maybe. Because I think all of our contact stuff is in there somewhere.
Oh, yeah, I think I just put mine.
Oh, great, Zach. Really
of
good.
Course.
Way to go. Yeah, yeah. So, so if you have any questions, or if you need free work done, call Zach. He'll do it all.
Thanks, Doug.
Just kidding. Just kidding. So yeah. Anyway, it's Doug.Cluck and at NOAA.gov, and there's Zach, and then there's Dennis. But anyway, we all know each other.
Don't email Zach asking about corn questions. I think he'll probably defer.
I will definitely defer to you, Dennis.
Anyway, I want to say thank you, everybody who got on today. We appreciate you coming, and we'll do this again next month. Dennis will be quite lively, I'm sure. Dennis will be the speaker. I guess Kevin Lau is saying 60%. Oh, whoop! Couple more questions here. 60%. South Platte projections for water supplies well below 60% is down to 60%. Which Niña, neutral, or Niño increased probabilities of a dry summer? And the answer to that is it depends on where you are, unfortunately. Dennis, why don't you deal with that while I'm trying to figure out this webinar thing?
For our region, La Niña has at a higher risk of warmer and drier, though the probabilities are not that much more. El Nino during the summertime would be the opposite, where we'd have a better chance of more moderate conditions, less drought conditions, but they're not exact in either case.
Yeah, and I think east to west, I think there's going to be some changes in there too.
Yes, plains definitely higher risk during El Niño or La Niña summers, less of a risk in the eastern part of our region.
Yeah. Okay, thanks once again. I'm going to sign off, and I want to say thank you to Zach very much, and Dennis also for helping out today. We'll talk to you next month. Goodbye.